Okay, for question 9 on the madasmaths.com MP1 series, paper N, the figure above shows a kite ABCD, where the vertices AC have coordinates 4, 3 and 8, -7 respectively. The diagonal BD is a line of symmetry of the kite. Find the equation for the angle BD. Right, very simply, if you know anything about kites, these two diagonals are going to be perpendicular, and this point of intersection is the halfway point between A and C. So if we find this letter, I don't know, let's call it point E, then the coordinates of E are going to be the halfway point between them. So what you do is you find the halfway point of 4 and 8, and this is clearly 6. Or another way you can do them is you can add the two coordinates together and divide by 2. And the halfway point between 3 and -7, well, let's do that. 3 plus -7 over 2. Well, 3 minus 7 is -4, divided by 2 is -2. Next thing I need to know is, because B to D is perpendicular to AC, that must mean the gradient of AC is the negative reciprocal of the gradient of BD. Simple geometry facts there. So we need to find the gradient of A to C, and we can do that by the change in Y. So 3 to -7 is 10 down, over the change in X, and 4 to 8 is 4 along, and -10 over 4 is -5 over 2. So that means the gradient of MBD is the negative reciprocal of that, which is positive 2/5. So what it's asking me to do really is find the equation of the line that goes through the point 6 - 2 and has a gradient of 2/5. So if y equals m, which is 2/5 lots of x plus c, I need to work out what this c is, knowing that it goes through the point 6, -2. So when y is -2, I'm going to have 2/5 of x, which is 6, plus c. 2/5 of 6 is 12/5. Plus c. -2 is -10/5. So if I'm -12/5, I'm going to get -22/5 equals c. So the equation of the line is y equals 2/5 of x plus c, which is -22 over 5. I mean, that's one way you could write it. Or you could times everything by 5 to get 5y equals 2x minus 22. And then if you minus 5y and add 22, you could write it as 2x minus 5y equals 22, or some multiple of that. It honestly doesn't matter. But either way, either this or this, they're both equivalent forms of an equation of a straight line.